everyone, and welcome. Thank you all so much for joining us today for this live stream event. My name is Alexia, and I am the Project and Event Manager at Microsoft Reactor Toronto. Before we begin, I'd like to quickly go over two items with you, our Code of Conduct and Event Guidelines. First, please take a moment to review our Code of Conduct. Microsoft Reactor seeks to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. Secondly, our event guidelines. This session is recorded and will be available through the Microsoft Reactor YouTube channel in about 24 to 48 hours. I will be sharing the link for our YouTube channel in the chat shortly. If you have not been on a live stream through YouTube before, please note that you must create an account on YouTube in order to access and interact in the chat. You can set that up now, and if you're unable to use the chat but have questions, please feel free to reach out to us through social media or on Meetup. Which brings us to today's session. I'm going to bring in our speaker here. Hello, how is it going today?
Hi, Alicia. Thank you so much for having me.
We're so glad to have you again here. Today's session, your AI journey on Azure made easy, super exciting. Very exciting topic. Can't wait to see the rest. Take it away.
Thank you, Alicia, for the introduction. So my name is Jaya Matthew. I'm a data scientist here at Microsoft. So I've been here for roughly about 8 years. And I kind of thought that it would be helpful for the audience to kind of learn how my journey has been through Azure and how I can simplify the process for the audience. Okay, so this is our agenda for today. It should roughly take us about 50 minutes, and I should have about 10 minutes at the end for questions. So in case you have questions, please put that in the chat, and we should be able to address it towards the end of the talk. That would be easier. So the agenda is as follows. So part one, we first look at defining what is AI and some of the common use cases that most of us come across in our day-to-day lives. Part two, we'll look at getting started with AI in Azure. So there are a bunch of options. The easy one is the pre-built option. And in case these pre-built options don't work for you, the custom AI option is something you could consider. So that comprises of Azure ML Designer, the notebooks, and virtual machines. Part three is essentially how do you leverage Azure ML to build your own models. So I would outline a design of a typical machine learning framework that most people follow. Then we look at what Azure Machine Learning Service is, then do a technical deep dive of the various components on the portal within the service, and then we'll get started with a Python SDK example with the MNIST dataset. At the end, I will leave you with some of the links to the documentation and how to get started, and that should hopefully make your journey on Azure ML much easier. Okay, so now let's first get started with some common AI and use cases that we've seen. See, over the last 2 years, most of us have been working remote during the pandemic, and we've used either Teams, Zoom, while working remote. So Teams meetings have become quite common, where we actually have your video as well as some text. So that's essentially, how does the text come in these calls? That's essentially speech to text. So this is live captioning that is powered by AI under the hood. Then most of us use search engines when we search for some topic of interest. So in here is a screenshot of Microsoft Bing, where I am kind of trying to learn a little bit about deep learning. So in the little text box, when I actually type up what is deep and I start writing LE, it immediately prompts us and says, well, are you looking for deep learning? In addition to just completing the word, it also gives me similar other searches, which is, are you looking for deep learning software, deep learning AI, deep learning in education? So this kind of recommendation in search engines is also something what AI helps under the hood. Then there were the days 2 years prior when we used to all go traveling, and if you land up in a place that you don't know the language, you might end up using the translation service like the Bing or the Google Translate. So here's an example, the screenshot on the right, where I'm trying to say hello in a different language. So assume I go to India, I do not know Hindi, and that is the national language. I would like to know how to say hello. So obviously it gives me the translation in the native script. And if I obviously knew, I would not know how to read the native script. So it also has a transliterated option where it kind of gives it in the English text, which is namaskar. Has also the audio option as well as how you could use this word in a sentence. Okay, so all in all, AI is almost everywhere. I mean, it's gaining popularity across different domains. So some are search engines and content filtering, like in Google and Bing, product recommendation systems like Amazon and Netflix. So we see a certain genre of movie, series, then kind of recommend similar ones for us to watch. Then speech recognition like Alexa and Siri, that we use in personal assistant. Then finance and predicting stocks like Goldman Sachs, Morgan Stanley all use some sort of forecasting and prediction. Then in Facebook, the moment you upload a photo, then it kind of detects the face or the object and enables you to tag it easily. So AI is almost everywhere. Now let's actually do one slide of what is AI and ML. Let's kind of define it. So in simple terms, machine learning is the process of teaching a machine to do something repeatedly. Okay? Artificial intelligence can be understood as the process of applying machine learning to solve real world problems. And AI and ML together, it's helping us solve some of the most challenging problems. Like think of self-driving cars or image recognition to fraud detection in the financial domain. So it gets used across multiple domains, but the techniques are similar but taper to different domains. So now what is this difference between traditional machine learning versus DL, which is deep learning? So traditional machine learning has some input data that you provide to the model, and the features that are built on this input data is typically handcrafted by the analyst or the data scientist or machine learning engineer. And then you kind of apply some machine learning algorithm, let's say support vector machine, SVM, to detect, let's say you're trying to determine if in the input image there is a person or not a person. So it kind of builds this classifier to determine if there is a human in the input image or not. Now, when we think of deep learning, you give it the same input data, let's say an image. The feature learning, the neural network under the hood takes care of it. So no human being needs to handcraft these features. So it kind of is able to extract low-level, mid-level, and high-level features, and on its own determine if in the image there is a human or not. So this is the main difference between the traditional machine learning and the deep learning. Now, as I pointed out earlier, so some of the applications is self-driving cars, machine translation, like in Google and Bing, predictive maintenance. When does the elevator in a building need to be repaired? Or when is an ATM machine likely to fail? Image recognition, so you upload an image on Facebook, maybe it recognizes it as one of your friends in the list. Forecasting, is a particular stock going to increase or decrease in terms of price? E-commerce recommendations like on Amazon.com, then genomics for COVID, there was quite a bit of AI and ML being used. So now, why do we need AI? So 91% of the enterprises that were surveyed said that they plan to use AI in the next 3 years. And out of which 37%, that's roughly 1/3, have started using AI in some form or the other. And the main challenge that organizations face is lack of skills. More than half of them say that they just don't have the people who have the right skill set. Then some of them, a third of them, are still trying to define the AI strategy. When defining the strategy, you also need to ensure that the data is available, does it make sense for the business use case, as well as another one third, which is 35% are still identifying the use cases. Okay, so in terms of AI adoption, so like I alluded to earlier, the AI and ML maturity varies across organizations, enterprises, and big businesses. So some organizations, depending on the level of maturity, prefer to use pre-built AI options. So pre-built is essentially no code, low code. So these models have already been trained on a large amount of data, let's say from Microsoft or Google or Amazon, and then they are ideal to use in some sort of use cases and problems that are similar in nature. Example, so supposing you're trying to determine the sentiment of a text or trying to detect an object, etc. So there are pre-built AI models in there, and you don't have to reinvent the wheel. Just go ahead and use that. Custom AI models, on the other hand, so supposing these pre-built AI models don't suit your use case at hand, you might want to use the custom AI models, which is low code or all code. So this is when you're faced with a unique problem and the firm might want to use their customized AI solutions and they prefer to write their own code in R or Python. So that's when you kind of look at the custom AI model route. So then, depending on AI adoption, once you build a model, what do you want to do with the model? You want to deploy it onto the edge and maybe have some real-time scoring, batch scoring. So these are all different considerations that you want to think about when you plan to use AI in your organization. Okay, so now let's get started with how do I actually use AI on Azure? Okay, so now if you think of it, like I said, the pre-built option is the very first layer where you have solutions for vision, speech, language, and search. So these are domain-specific pre-trained models, and these are quick to use, so they reduce your time to market. Then if you are interested in building custom models, and your organization has people who are familiar with data science tools and some languages like R or Python to simplify model development, we support PyCharm, Jupyter, Visual Studio Code, and if you're most comfortable with command line, that's also supported. Then we also support popular frameworks to build advanced deep learning solutions like PyTorch, TensorFlow, Scikit-learn, Onyx. Then we have some of our productive services to empower data science and development teams, like Azure Machine Learning. We have our virtual machines, Azure Databricks, and this all runs on very powerful infrastructure to accelerate deep learning. So we have CPU-enabled virtual machines, GPU-enabled, and FPGA machines. Okay, so now let's look at some of our pre-built options. So if you want to look for our pre-built options, it's something called Azure Cognitive Services, and you have a bunch of services which helps you make decision based on language, speech, and vision. So these pre-trained AI models have their APIs that you can easily use. And since these are hosted on the cloud, you don't have to actually worry about computational requirements, algorithmic optimization, or even any security things. Now, let's look at an example of the text analytics API. So this is a pre-built AI option. So right on the website, you could put some text in the text box, and if you send this text to the API endpoint, it would analyze the text. And in this case, it kind of determines that the language is English with 100% confidence. Then it also extracts some key phrases from the text that you've provided, determines the sentiment of this overall document. It says that, well, it's quite certain that 86% of the document contains positive, whereas about 14% is negative. So it's kind of a mixed document. Most documents are like that. And then if you want to use the results from this API endpoint, it also gives it to you in JSON, so you can actually use the JSON to store the data in some database or stream it to some dashboard. So we also have Azure virtual machines for data science. So these data science virtual machines are very easy to use because on the machine, we support different languages like C#, Python, R. We support different deep learning tools, then data visualization, exploration tools, as well as for data ingestion, development tools. So all this is already pre-installed on the virtual machine, so you don't have to actually think of all the drivers and have to install and maintain it. Okay, so now what if these pre-built options don't work for you? We actually don't have a pre-built scenario that suits your use case. So that's when you think of using the custom AI, Azure Machine Learning. So this is something that you can provision from our Azure portal. Towards the end of the talk, I'll kind of show you how you can search for it. And then once you get into this, you have something called the Azure Machine Learning Studio, where on the left side, you can see that I can author notebooks, you have Auto ML, you have the designer, a bunch of assets, and how do you manage all these resources. So we'll get into each one of these sections in part 3. So here is an example of Azure Machine Learning Designer. So this is where I would start if I was someone new, not very familiar with R or Python. So there are easy to use pre-built modules, and you can build your own pipeline. So let's kind of see how that's done. So here's an example. On the right side, you have the canvas, which is like a graph. So maybe you're looking at the flights delay data set. And then you want to normalize the data, but prior to normalizing the data, you want to clean the missing data. So as you can see, if I want to clean the missing data, on the left panel, I can look for the clean missing data module, just connect the output of the flight's delay data as input to the clean missing data, and then the output of clean missing data to normalize the data. So essentially, this is a graph that you can just drag and drop from the left panel into the canvas and create an experiment. So this is low code to some code. So, I mean, they allow you to also write code in Python and R. So you have those modules as well. Okay, so what if you want to write the entire code? So essentially, you have the option of creating notebooks. So you can create Jupyter notebooks similar to other environments like Jupyter Hub. So and you have the command line experience where you can kind of give the file name, select the type of notebook, create the file, and then write the code on each cell and then execute it just like you would in any other environment. So in here, we do support the IPython notebook, .py, Python scripts, .r scripts, bash script, text scripts, and others. And you can also run the code via terminal. Okay, so now that we know what is available, let's actually look at an ideal machine learning framework. What should you look for when you're actually looking for a machine learning framework? So this is how a typical end-to-end process looks. So essentially, you first prepare your data, then you experiment. You either write code in Jupyter or VS Code in your favorite IDE. Then you, using your data, train and test some model, and then try and fine-tune the hyperparameters. And once you found the best model, you kind of register and manage the best model. And then you deploy the best model. You build the image, either a Kubernetes endpoint, and then deploy the service. So this entire process needs to be orchestrated and managed under the hood. So step 1 is to prepare the data. So nowadays we also have the DevOps loop for data science, where you first, you have your data, you build your model, you train and test, then you register, build the image, and deploy. And once you deploy, you see that the model's not doing well, go back to the drawing board and maybe change the algorithm and see if it actually improves, or maybe your data needs to be improved, do some data cleaning, etc. So in terms of data preparation, so most platforms, we want them to support multiple data sources. So let's say SQL, NoSQL, then cloud stores, like it should connect to blob storage if it's Azure, HDFS, support multiple data formats like binary, text, CSV. Then you have to be able to clean the data, some sort of, fix missing values, outliers, out of range, look for duplicate rows, transform data. So you want to actually transform general data transformations as well as ML specific, like normalizing, binning, etc. Then the next thing is when you build a model, you want an environment that gives you the choice of algorithm that you want, maybe the choice of language, R, Python, then choice of development tools, so a browser-based, a REPL-oriented, a notebook such as Jupyter, PyCharm, Spark notebooks, as well as a desktop IDE. So maybe Visual Studio Code, Visual Studio, RStudio for R development, etc. Then it is good to have the option to do local testing before you actually submit this job to, let's say, the cloud and run on much more expensive, powerful infrastructure. Then is model training. So you also want to have powerful compute environment. So you should have the choice to scale up your virtual machines, auto scaling of clusters, then you also want some pre-configured. The compute environment should be pre-set up with the correct versions of the frameworks, the libraries, the container images. Then in terms of job management, you want an environment where you can easily start, stop, monitor, and manage jobs. And if you have some sort of auto ML feature, like automatically select the best algorithm, the best hyperparameter, that is also desirable. Next is once you've found the right model, you obviously want some sort of mechanism to deploy and use this model in your production environment. So you want to containerize it. So some sort of functionality to automatically convert these models to Docker containers so that they can be deployed in some production execution environment. Versioning of models. So maybe you're running a bunch of models and then you want to have version numbers, you want to track changes over time, you want to actually be able to retrieve certain changes, do some sort of A/B testing, rollback in case the latest model doesn't work well in production. Then all this, typically you want this to be stored in some sort of repository where, let's say maybe a GitHub repository where you have CI/CD pipelines when you check in code, make commits to the repository, etc. And you want to actually track these experiments for auditing. So in case you're actually deploying some of this in the financial domain, so you have regulatory requirements for you to be able to audit and track model performance. Then model deployment. So here you want the choice of deployment environments, like a single VM, a cluster of VMs, a Hadoop cluster, etc. Then you also want edge deployment. So you want to be able to make these predictions happen closer to where the data is to avoid data transfer from the device to the cloud. Then all this has to be secure. So end-to-end security must be maintained, as well as you want to monitor the status of these models' performance and security. Okay, so now that we've seen what an end-to-end framework typically looks like, let's actually look at what Azure has to offer. So in terms of model creation with Azure ML Platform, we have the following development tools: the Visual Studio, Visual Studio Code, then PyCharm, Jupyter Notebooks. We support R, Python. We also have a bunch of frameworks like scikit-learn, TensorFlow, etc. So now let's actually define what is this Azure Machine Learning Service. It's essentially a set of Azure Cloud Services with Python SDK that enables you to prepare data, build models, train, manage, track experiments, and deploy models. So we'll get into each one of these steps over the next few slides. So let's look at what the end-to-end AI ML lifecycle would look like in Azure ML. So the workflow is as follows. You develop your machine learning training scripts. Most of us do coding in Python these days. Then once your training script is ready, you create and configure a compute target. So that's where you run the training script. Then you submit the scripts to this compute target, and then it basically creates some output. Then you save the output. Then you can query the experiment for log metrics like accuracy, F1 score, precision, recall, whatever. Then step 5 is essentially, once you're satisfied with that run, the model, you register the model, you persist, then you develop a scoring script, then you create an image and register it in an image registry and then deploy it as a web service. So we'll get into each one of these steps and then show you how this is done via Python SDK as well as on the portal. Okay, so now the first thing is, how do you get started? Where do you go and find this Azure Machine Learning Service? So if you log into the portal, you want to search for create a resource. You want to search for machine learning. And typically the very first machine learning result would be machine learning offering from Microsoft. So there are other things in the marketplace, so you want to look for the one from Microsoft. Then you select create, give it the details as to which region you want to provision, how many clusters, and what kind of machine do you want, just a CPU machine, a GPU machine. So the pricing, everything varies based on the configuration you're looking for. So once you've provisioned, within the resource group, you'll see a bunch of resources being provisioned. So you want to look for the machine learning service workspace. Once you click on it, it opens similar to what we saw earlier. So on the left side, you have the home button. Then you have a bunch of things to author, either notebooks, AutoML, Designer. Then you have a bunch of assets. We will get into what each of these assets mean. So you have the data set, the experiment, the modules, pipelines, models, and endpoint. And then you can manage your compute resources, data stores. We also allow you to do data labeling, which is nice, everything in one environment. So you can kind of have multiple labelers label the data, and then you could use that to build your model. So if you go to the data labeling and you say, well, I want to build an image classification, which is multi-class, and then you can kind of upload your data, have multiple labelers, use the same workspace, label the data, and then use it to build a model. Okay, so now let's actually get into each one of these artifacts that we looked at. So I think if you look at this screen, you see assets, you see data set, experiments, modules, pipeline, models, and endpoints. We will get into what each one of these mean. Okay, so what is a workspace? So we have this concept of a workspace, which is a top-level resource for Azure Machine Learning Service. It essentially provides a centralized place to work with all the artifacts in your Azure Machine Learning Service. So you can run your script, then your models are registered in the workspace. You can create multiple workspaces, have people, multiple people access the same workspace. And then when you create a new workspace, it essentially creates something called a container registry, storage, key vault, and application insights. So as soon as you provision, you get all this under the hood. Then once you kind of run your training script, you typically have something called a model that's generated. So what is a model? A machine learning model is an artifact that's created in your, once you run this training script. So you can use this model to get predictions once you have a scoring script and you deploy it. So Azure Machine Learning is framework agnostic, so you can use practically almost all the popular machine learning frameworks for creating the model. So what is a model registry once you have a model? So model registry helps you keep track of all the models in the Azure Machine Learning workspace. The models are identified by name, version, time that you ran, and then you typically, if you're using the model for an endpoint, you can't delete till the endpoint is deleted. Okay, so now let's look at how this would look. So if you look at the very first thing, the first thing is data sets and models. So if you look at data sets, I can upload data sets. I can connect to a different Azure blob, and it kind of lists the registered data sets. And then if you click on a specific data set, it'll give you all the details about the file and give you some sample and also tell you how to unregister some data. Now, what are runs and experiments? So once you kind of run a training script, that's called a run. So an experiment is essentially a grouping of many runs from a given script. So maybe a training script, I run it with different hyperparameters. So each one produces a run. So in a run, you actually have the metadata about the run, the timestamp duration, the metrics that are logged by the script, output, as well as snapshot of the directory that contains the script. So I will actually get into the workspace and show you how that is. Okay, so in here is an experiment. So if you look at the very second artifact, the little beaker, so that is where you have the experiments and the runs, and then it gives you the run number, ID, and then what was the name of the experiment that you ran, and some metrics that was logged was accuracy in this case, status, is it provisioned, is it running, is it completed, failed, then what time was it submitted, how long did this experiment take, duration, who submitted this particular run, against which compute target was it run, and was it through a script or a Jupyter notebook. And then you can always give it some tags so that it's easy for you to retrieve a specific run. Okay, so then once you have all this, you might want to orchestrate this whole thing and have a pipeline. So an Azure ML pipeline consists of a number of steps where each step can be performed independently or as part of a single deployment. So here is an example where you want the pipeline to enable data science engineers as well as professionals to orchestrate the data preparation, then the build and train, and the deployment. So this can also be done via the pipeline feature. Now, in terms of compute target, where do you kind of run all these training and scoring scripts? So compute targets are essentially compute resources used to run your training scripts. So if you look at it, for training, people can run the training on local compute, but most of us don't do it. We might have a data science virtual machine, which is a Linux Ubuntu machine, or Azure Machine Learning has their compute, Databricks has their compute, Data Lake Analytics, HT Insights. In terms of deployment, we support ACI, which is Azure Container Instance, AKS, which is Azure Kubernetes Service, IoT Edge, as well as Field Programmable Gate Arrays, which is FPGA. Okay, so in terms of if you're looking for specific things like GPU acceleration, hyperdrive, automatic model selection, can it be used in pipeline? We would typically recommend either using the default Azure Machine Learning Compute or a data science virtual machine. With the other ones, it might work, it might not work. Okay, so now where do you look for all these compute targets? So again, within the same portal, if you look at manage section, so we are done with all the assets. Now, if you look at the manage section, it has the compute, and then it has the compute instance, the training clusters, inference, and all the details are provided in this page. Okay, so now let's actually look at what is an image and a registry. So once you build a model, you run the training script, you get a model. The image contains a model, a scoring script used to pass the input to the model and return the output. And then if it needs some specific dependencies, it has the script for the environment as well. So the image registry, it keeps track of all the images created from the model as well as metadata tags that can be attached to the images. So obviously we have two types of images. The ones we would focus on is a Docker image, which is used to deploy to compute targets such as ACI or AKS. So Kubernetes and service or container instance. Now you also have this whole concept of model management. So one of the things is typically model management in Azure ML involves 4 steps. One is you register the model using the model management. Then you register the image using the image registry. Then you deploy the image to the cloud or the edge, and then finally you monitor the input, output, how is your endpoint performing, etc. In terms of deployment, like I said, we would be focusing on the web service. So there are 2 options, either the web service or the IoT module. So the web service, essentially, you can deploy the web service as an Azure Container Instance, Azure Kubernetes Service, or an FPGA. So it can receive scoring requests via a load balance HTTP endpoint. You can monitor by collecting application insights telemetry, and it can be automatically scaled in case you expect a lot of traffic for the endpoint. So how do you typically deploy models at scale? So you have your Azure Machine Learning experimentation or the cognitive services. You have the model registry where you register the model, that you have the scoring file. It's typically a score.py or something. And then you create the image, which consists of the scoring as well as the model. Then you deploy it either as a cloud service, heavy edge, light edge. Then you can monitor the deployment. Okay, so now let's actually look at how to use all this using command line and code. So this is an end-to-end coding example. So these are the steps. So typically you're working on your computer, which is on the left, and you're trying to interact with the Azure Machine Learning Workspace, which is in the cloud. So the first thing is you send a snapshot folder and send the experiment to your machine learning workspace. Then you create a Docker image. Then you deploy the Docker and snapshot to the compute target. Then you mount the data that is used for this training or scoring. Then you launch your script. Then you stream the output, logs, metrics, and then to the experiment as well as finally to your computer, and you can view it. And then you can copy over the outputs to any location that you need. Okay, so now for this example, we'll look at the popular MNIST dataset. So the MNIST dataset consists of about 70,000 grayscale images, and each image is a handwritten digit, like you see in here, 5, 0, 4, etc. And it's any number from 0 to 9. So the goal is to create a multi-class classifier to identify the digit that the image actually represents. So this is a typical use case. Let's think of the USPS Postal Services or Canada Post. So essentially, they might want to kind of scan and see which zip code a certain mail or letter goes to. So this could be used for that. So the overview of the steps that you would typically do is you want to create a workspace, you want to create an experiment, create a remote compute target, then you upload the data to the cloud, then you can train on local, or if you do not want to train local, you can skip step 5. Then step 6 is you want to train the model on the remote cluster, then monitor the run, see the results. If you're happy with the results, then register that particular model and then deploy that model and test the endpoint. Okay, so now step 1, create the workspace. So if you don't want to do via the portal, all this can be done programmatically via code. So essentially, from the Azure ML.core library, you import workspace, then you just say workspace.create, give it the workspace name, your subscription ID, resource, and the location that you want. Then that would kind of provision a workspace for you. Next, within the workspace, you want to create an experiment. So give it an experiment name. In a workspace, you can have multiple experiments. Again, from Azure ML Core, import the experiment, and then give it the workspace name, and you need to give it an experiment name. Next, you want to create compute targets against which you will be running your script. So here you're kind of calling your cluster name as, let's say, batch AI cluster, and then you kind of say that you need a minimum of 0, maximum of 4. So typically, in this example, we're using a standard D2V2 VM, which is a CPU virtual machine. In case you want a more powerful GPU machine, you can use the standard NC6. So if you go to the Azure Portal, it lists a bunch of virtual machines and gives you the price per hour. Then what you do is you do AML compute. You just provision, give it the VM size, the name, and it would provision the virtual machine for you. It takes some time depending on the availability of the virtual machine as well as the region that you're trying to provision in. Next is the data set that you have to train. You want to upload it to the cloud because it has to be available within the Azure Machine Learning Workspace. So in here, you have the train and the test. So you have the X values, which is the image, as well as the Y values, which says the actual number, the labels. Then you want to essentially, you have a default data store, just upload it to the default data store into the data directory. Next, this is a case where you could actually train a local model. So in case, let's say, you're interested in building a logistic regression, So you just, from scikit-learn, linear model import logistic regression. You want to instantiate the logistic regression classifier, classifier.fit. So this is using a train data, X train, Y train. And then you basically, using the classifier, you predict using the test data that you did not use for training. And then you want to compare if the actual Y test and Y hat is quite close or not. So one of the metrics that you'd look at is accuracy, and maybe this model, MNIST, the data set is quite good. So it says that a logistic regression model gives you a 91% accuracy. Next is you want to actually submit this training job into the remote cluster. So here you create a directory, create the training script, create an estimator object, and submit. So the first step is create a directory. So you say, well, I want to create a script folder, which is the root, sklearn MNIST, and then you create a training script. So this is where you're going to do the entire thing that we did in local, this entire, instantiate the classifier, fit it, as well as predict. So essentially what we're doing is we have to define where the X data is. You want to load it from, the data folder, and then you have to get hold of the current run. And then this is essentially the same thing that you did in your, local run. You instantiate the logistic regression model, you fit it, and then you look at the difference between Y hat and Y test, determine the accuracy, and then you want to save all this into the output folder, outputs sklearn MNIST, with the model file. So now you also want to create something called an estimator. What is an estimator? So essentially the estimator this is the directory that contains the scripts. All the files in the directory are uploaded to the cluster. For execution, then you want to give it the parameters required for your training script, the compute target against which the script is going to be run, the name of the training script, the Python packages, maybe the Conda environment. In this case, it just needed scikit-learn, so that's the only Conda package that you need. Then you essentially submit the job to the cluster for training. And what happens after you actually submit the job? It creates an image. Then it depending on if it needs to scale, it scales, it runs the job, and it does the post-processing, and it outputs everything into this .outputs directory. Okay, so while this entire process is running, you might want to monitor. So some of these jobs take just a few minutes, some might take a few hours. So you can actually look at the run details to monitor the run. So it'll kind of tell you, in this case, the screenshot says that this job was started at a certain time. It took about 7 minutes. And then what are the arguments? What was the overall accuracy? And the status is it's completed. It can also gives you the output logs. We'll kind of look at this on the portal. Then if you want to look at these results via command line, you actually just say run.getMetrics, and it'll show you, well, the same accuracy and regularization rate. Once you're happy with the model, you want to actually register it. So essentially what you do is, in the last step of the training script, if you look at this one in here, you did a job lib dump, and you're actually dumping the best model, the only model in there. So in this folder outputs, there is this pickle file, which is the model. So what you do is you pick this model and you say register the model. You say give it a name, give it the location. This is the same location where you dumped it from your training script. Now you're ready for deployment. So for deployment, essentially it creates, just like you created a training script, you need to create a scoring script, create the environment file, configuration file, and then decide if you want to deploy to ACI or AKS. So most of us typically deploy to ACI, see if the script's working before deploying it to AKS. So here is how you'd create a scoring script. So essentially the scoring script consists of two main functions. One is the initialize, the init function, which typically loads the model as a global object. And this function is run only once when the Docker container started. So the heavy lifting is done just once. Then you have a run function, where you get the input from the endpoint, and this data is taken in, and maybe it's a JSON input. So you kind of read the data into the format that you need for the prediction. Then the previously loaded model from the init, you just predict and return the output. So the run function essentially uses the model to predict a value based on the input data. So the input data is typically JSON. It needs to be serialized or deserialized, and other input formats are also supported. So typically you also need to create an environment file. In this one, it was very easy. So you're essentially just creating a myenvironment.yaml. You only needed scikit-learn, so that's the only thing. So in case you have a wheel file or other things, you want to add more conda packages. Then you want to create a configuration file. In this case, we're trying to deploy to Azure Container Instance ACI. So you just say ACI Web Service Deployment. You just give it the number of cores you want, memory, tags, description. And then you essentially deploy the model. So essentially here, when you say to deploy, you actually want to give it the scoring file that you just defined in here. This is your scoring script. Then you want to give it the environment file that you just defined in here, as well as the configuration file. And then you say web service deploy, and it would deploy sklearn MNIST service. Once it's successfully deployed, you should actually get the endpoint details, and you can send a post request to the service scoring URI, and see if the output makes sense and it's not timing out or there's some error when you invoke it. Okay, so most of this code, if you're doing command line, can be run through Visual Studio Code right on your machine and connect to Azure remotely. So essentially whatever you see in the portal, you can actually see it via the command line in Visual Studio Code. The output can be viewed, using a Power BI dashboard. And before I get into the resources and links, let me actually quickly show you how this looks. So let's see. So this is how you would go into your portal, ms.portal.azure.com, search for create a resource, look for machine learning, then you just say create. You need to give it a bunch of details as to region, etc. Then once you've created, you can kind of go to the homepage, and then here you can create your compute instances, and then the compute cluster, inference cluster, etc. Then if you're getting started, go to notebooks, look at some of our samples. We have a bunch of tutorials. Just use one of them, clone it, and then run it against one of your compute instance. And then if you have an experiment, so here I have a particular experiment that I'm running, then once it runs, it kind of says, well, the status is completed, failed. So I obviously had some fails, some were canceled, queued. So when did I submit it? How long did I take? It was submitted by me against a specific cluster. It was a script, and gives me the metrics. Okay, so now in here, I kind of list some resources for you. So let's actually look at some of these resources in some detail. So if you look at it in here, so this is your page where you get a brief overview of Azure Machine Learning. We have a bunch of documentation, as well as some getting started, tutorials. Then if you're interested, we have the MSLearn. So in here, you can kind of look at each one of these different modules and paths to learning Azure Machine Learning Fundamentals, Azure Fundamentals. We also have the AI School, as well as I think most of the recordings come into the reactor. So you have a bunch of different playlists. Look at them, and maybe some of them are useful for you. So, yep. So that is, I think, pretty much what I had. And now I guess I'll stop sharing, and we can address some questions if there are any questions. So I have about 10 minutes for that. So okay, so let's actually look at if anyone has any questions. Okay, so let's. Okay, so maybe I will get started with I think Samira's question. So, can every language be used? So, I would say that I think Python is what we typically support. We also support R. Okay, so then hopefully that addresses your question. If Okay, I think Samira had one more question, which is in step 4, upload data to the cloud, which language should be used? So I think, again, I use Python in most cases, and I do think we support R, but Python is the preferred language of choice, and hopefully that works. Yeah, I would say that. Okay, so then Nicola has a question. So I'm here for a school project in my university. Do you think AI is something more and more students will start working on, especially now that it's more accessible through platforms like AI? Well, I would think that the adoption of AI, and especially, I think you have it through Azure as well as Google gives a bunch of Colab notebooks as well as Google credits. So I think, yeah, more students. I do envision. I think even curriculum in your degree programs. I think they will kind of encourage you to collect data, maybe build some AI models, and I think cloud platforms just makes everything much easier. So hopefully that addresses your question, Nicola. Okay, next is Michael had a question. These code examples are all being run through a notebook in Azure ML? Not necessarily. So some can be run using the notebook. Some are also run using scripts, .py scripts, not just .ipynpy. So, okay. Then I think there are some more questions that are coming in. Okay, so let's see. Uh, yep. Okay, so I guess those are all the questions. I'm here for any more questions. In case any questions, let's see. Yep. How can we get a copy of the? I think Dan had a question. How can we get a copy of the presentation with the links? So I can actually share a PDF of this to um, uh, in the Reactor homepage. So what is that? Yeah. So
Yeah.
I think Alicia might be able to share the presentation and the link.
Yes, I can just answer that directly. So Dan, Oliver, and everybody else, all of our sessions are recorded. So you will have access to this recording on our YouTube channel in about 24 to 48 hours. I share the link here. Yeah, and you'll have access to the presentation on demand.
Thank you.
Yeah, it looks like it's about it for questions for now. Is there anything you wanted to add?
No, nothing else. Hopefully, this was a good use of your time. Thank you for
Yes,
joining. I know it's a
absolutely.
little late in the evening.
No, and I think it was all pretty clear. And definitely great content. We'll leave it up for questions for another few minutes. I'm just going to jump in here. If you have a moment, please share with us your experience for this session. I shared the link to our survey, and the event code is on the screen as well as in the comments. And we are, as mentioned before, on YouTube. Those sessions are being recorded and will be available on demand in 24 to 48 hours. We're also on Meetup. If you're interested in joining more sessions from the Reactor, you can find us there, as well as other social media. And yeah, just having a quick look in the chat here if there's more question. Again, feels like everything was pretty clear.
Okay.
Awesome. Well, Jaya, thank you so much for joining us today. This was a great session, and we hope to have you again very soon.
Thank you very much. Talk to you all later.
Bye.
Bye.
Have a wonderful evening. Bye.
Bye.